Hello everyone, today we are going to talk about problem 529 Minesweeper. So this one is kind of can be done both in DFS and the BFS, but today I'm going to talk about the BFS solution. So you are given basically a matrix, char matrix, which is a board. So if you have played Minesweeper, when you are a kid, so it's like try to identify or induce which cell in the matrix is a mine and try to avoid the mine. So here M represents an unreviewed mine and E represents an unreviewed empty square. But if a cell or empty or square shows empty, that means there might be some mines across that adjacent area, or there might be a blank square that has no adjacent mines. So if it has adjacent mines, then we can count how many mines it has in the adjacent area. So if, for instance, here I have one empty cell, and then I count how many mines across the adjacent area. So I have 1. So here is set to be 1. And X represents a reviewed mine. So once the mine is reviewed, the game is over. So this is the basic rule for Minesweeper, and this can be done both in BFS, which means breadth first search, or depth first search. So here I'm gonna use the breadth first search first, and then maybe tomorrow I'll talk about the depth first search. So there are actually two elements in the breadth first search. Actually, so the first one is a queue. So the queue used to keep a record of what are the elements that needs to be visited in the future. So in order to keep record of what are the elements that need to be visited in the future, we also need to have a keep record of what elements have been visited or not. Here we use a variable called sin. It can be, here I use a set to save some space. Otherwise, if I create another board, which means it's a n times n square, that can cost some memory. So here I use sin as a set to keep record of all the elements that I have been visited. So once the element has been visited, it won't be added to the queue again. So this can help to save lots of time and avoid the infinitive loop. So okay, so queue is a data structure in Python. We can create a queue as a list, or we can use the queue DQ library in the collection package. So here I use queue in a collections dot DQ, and then first I get the value from click and assign the value to X and Y here. So first I use Q to append X and Y first, and then I use a direction to represent our adjacent neighbors given a certain cell. So direction. Here I also use a set. It can has 8 elements across one cell. So it can be -1 times -1 0 -1 +1 0, and then 0 -1, and then 0 +1 0 plus 1, and then 1 minus 1, and then minus 1 minus 1, and then minus 1 1, and then finally we have a last 1 1. So these are the 8 directions given a certain cell. All adjacent directions are here. So we need to iterate over all the direction to first identify how many mines in the adjacent cells, and then second try to identify if for the adjacent cell we need to add to the queue or not. So these are the direction we will use later on. And then for the scene, it is a set. And then the first element we have seen so far will be the x and y we add to the scene. Okay, so this is the initialization phase before we start the problem. So we will use a queue to keep a record of all the elements we need to visit until the queue becomes empty. That means we finish all elements we need to check. So we use a queue as a loop invariant. So first we pop from the queue. Sorry, pop left. And if board x and y equals to m, that means it's already a mine. That means the game is over, right? So board x and y equals to x, right? So that means game is over, and we need to break the queue. We don't need to continue the game anymore. And else if board x and y equals to here, it means a empty element, then that can be divided into two branch. So first it has we need to count how many mines across that cell. And the second, if we didn't find any mines across it, we need to assign the b value to the empty square, and then we need to decide what are the adjacent elements that need to be further explored. Okay, so here if it is E, then we need to set a variable. Here I called it n to keep record of all the mines across this across the x and y. So for I and j in the direction, if x is less than x, 0 is less than x plus I, and less than is keep checking the boundary, or and 0 is less than or equal to y plus j less than length board 0. That means we are still within the boundary of the board. So if board x plus I and y plus j equals to mine, then we will add 1 to the number of n. After that, we will check if n is larger than 0. If that is the case, then we need to convert the n to a char or to a string, and then assign the value to the board. So here I will change the value of n to a string and then do this char assignment. Else, if board board xy equals to b, else if otherwise xy will be assigned the value of b. So for I and j in direction, we need to decide whether this element can be added to the queue. So in order to be added to the queue, it has to be satisfy two conditions. So the first one is it has to be within the range, and the second one is the x plus I and y plus j cannot be in the same set. X plus I and the y plus j cannot be in the same set. Only in this case, I will add the queue an element of x plus I and y plus j. Okay, and then finally we will return the board. No need to return the board. Sorry, we need to return the board. Okay. Right. Okay. Okay, now it passed. Okay, thank you for watching.